questions. Now, in the book, it's saying the amplitude's negative. That's not true. I don't know why the book is putting the negative with it. Because amplitude means distance from the midline. So even though the back of the book is saying negative on the amplitude, don't put negative. Okay, amplitude is 3. So we would just say 3. And then yes, we would be able to say it's a reflection. When it says describe the transformation, we'd say reflect over the x-axis. Okay, good. Now, number of cycles from 0 to 2 pi. Bx, that's the part. B is the number of cycles from 0 to 2 pi. So there are 2. So that means for sine, 0 max, 0 min, 0. There's 1 cycle. 0 max, 0 min, 0 ends at 2 pi. There are 2 cycles from 0 to 2 pi. Does everybody see? All right, so our period then, the length of just one of those cycles would be pi, or use the formula, 2 pi divided by b. So that'd be 2 pi divided by 2, which is pi. Everybody good with that? One physical length of one cycle is pi, which makes sense. So if we were going to describing the transformation, sorry, I didn't mean to skip that part. So reflect over the x-axis, technically a stretch of 3, or amplitude of 3. If you put amplitude of 3, also correct. We'd say down 5, that one's easy. And then don't be the person that says right pi. You got to be careful. It's actually right pi halves. Okay, good. Any questions on that? So if we were going to graph it, tell me the steps we would take. We would write down sine of x as xy points, correct? 0, pi halves, pi, 3 pi halves, 2 pi, and then 0 max, 0 min, 0, and then we would perform the transformation. So let's just talk about where you would do it. So we would times our y values by -3, wouldn't we? Then we would subtract 5 after that. So with our x's, the first thing you have to fix is your period. Right now it ends at 2 pi. It needs to end at pi. Don't we remember from last time learned that we times by the reciprocal of b? That makes sense because of the formula here. So we're going to times by a half, and then after that we're going to write pi halves, so we'll add pi halves. And that'll be your new xy point. So it'll be adding some fractions, but that's okay. Everybody have your calculator out so we can do it quick today. Like, I get that you can do it by hand. I agree. We all know how to get a common denominator. To be quick and efficient today, let's all just grab a calculator and add fractions by calculator, if you don't mind. Awesome. Okay, how did the homework go? Yeah, okay. So here's the thing, guys. On the test, I'm going to make sure to do a couple like this. Here's why. This is more likely what you would see on an ACT, something of this caliber. So it says, given this graph right here, write the equation for cosine. Given this graph, write the equation for sine. So we've just got to go fill in all the shifts and the b value, right? B is the number of cycles from 0 to 2 pi. Bx, right? B is the number of cycles from 0 to 2 pi. So what I want you to do is in groups, write the equation to this. I'm telling you it's cosine. Write the equation to this. I'm telling you it's sine. Now isn't cosine cycle max, 0, min, 0, max? And then sines is 0, max, 0, min, 0. Do you guys see why one would be cosine, one would be sine? Okay, try it. Go for it. Okay, so I'm telling you if this one's a cosine, so we know it's a length of a cycle, it's, I don't know what I'm saying here. The pattern for cosine is max, 0, min, 0, max. Agreed? Max, 0, min, 0, max. There is the length of one cycle. There's our period, correct? Great. Okay, well, awesome. How did you find out the amplitude?
So I thought of it as this, like, the median, like the middle line, it's not going to be at 0 because then it's uneven,
okay.
So it's shifted up one.
So you're saying this is our new midline?
Yeah.
So that's the halfway distance?
Yeah, and so then I was like, alright, so it goes up to 5 from 1, and it goes down to -3, so it was more fun.
Good, so it was a distance of 4 cosine. Now the bx part is the number of cycles from 0 to 2 pi. So you could count 1, 1 plus 1. I saw most of you get that one right. Very good. Okay, now let's look at the sine one. Where's the midline? 1. And then our amplitude is up 1, down 1. So we have y is equal to 1 sine. Now b, once again, now for sine you would say sine is 0 max 0 min 0. So 0 max 0 min 0. There's 1. 0 max 0 min 0. 2. 0 max 0 min 0. 3. 0 max 0 min 0. 4, and we're ending at 2 pi. Does everybody see? So it was also 4x, and then it was plus 1. Good job, that group. Awesome. Way to go. Questions on that? Now, here's the thing, guys. On the test, what if it was not, you guys could see clear to 2 pi, so you could very clearly count. What if they cut it off? Like, what if this was like a graph that was cut off here? How would we do the B part? Yes.
Well, you see that one cycle of pi half, and so you do pi half times 4, which is 2 pi, so you can use conditions.
Right, so you're using kind of logical thinking skills. Well, I can at least need a pi half, and there's 4 of those, so I need to times it by 4. Right, we need 4. There will be 4 of those. I didn't start. Everybody good with that? Well, how's another way? What if these weren't pi's? Like, what if these were, like, 1/2, 4/3? Well, guys, use this instead. If that happens, do period is equal to 2 pi over b. Now, you'll always be able to see a full period. Period means length of a cycle. So let's say that this ended at 4/3, for example, right here. How would you find b? Well, you would say, well, I know my period is the length of one cycle, which is 4/3. Do you guys see? So you plug it in. You'd say 4/3 equals 2 pi over b, and then you solve for b. So you times by b, times by 3, so that would be b times 4 equals 6 pi, right?
Yeah.
And then you would divide by 4. So our b value would be 3 pi halves. 3 pi halves. Which, remember, isn't that weird. We would just have a 3 pi halves right there. So just make sure you can use algebra to also find it using the length of the cycle. Everybody understand? Okay, cool. All right. We're going to be graphing all the other trig functions today. So we have to be able to really know how to graph sine and cosine to be able to graph all the other trig functions. So and you guys just did really good. You showed me you understand how sine works and you understand how cosine works. Do you guys feel pretty confident with those? Okay. So let's start out by reviewing rational functions. So just a reminder, if we have x plus 3 over x minus 2, we know x cannot be 2 or else we would be dividing by 0. You can't divide by 0. Well, that was where we got vertical asymptotes right here. This is 2 right here. So we have a vertical asymptote at 2 because we cannot be 2. Everybody remember that? Vertical asymptotes come from what make the denominator 0. We're going to have vertical asymptotes today. We're not going to have horizontal, but you do have to be able to remember how to graph this stuff for calculus. Can anyone, by chance, remember how we got the horizontal asymptote here? Yeah, so I'm asking now, how do we get this horizontal one? Can anyone remember? There was a way to do it. Yes. So she's noticing if there was 3 rules. If they're the same degree, you divide your leading coefficients. So 1 divided by 1 is 1. So this would be at y equals 1. Do you guys see? If the degree on top is smaller than the degree on bottom, can anyone think or remember where that went? 0. And if the degree on top is larger than the degree on bottom, we no longer had a horizontal asymptote, it was slanted. Like if this is degree 2, divided by degree 1, it would be degree 1, wouldn't it? So then instead we'd have a slanted asymptote. Okay, awesome. I just wanted to review. Now we're only going to see vertical asymptotes today because, just a reminder, starting out with graphing tangent. Everybody write this down. Y equals tangent of x is we are technically graphing y equals sine of x divided by cosine of x. Because we're dealing with fractions, we can't divide by 0. Therefore, tangent will have vertical asymptotes in certain places. Now, because cosine can't be 0, just a reminder, if we look on the unit circle here, cosine is the x value. So if you look, the x value is 0 there and there. That's where cosine is 0. Does everybody agree? So that's where there's going to be asymptotes. We cannot calculate the cosine at pi halves. Agreed? Because it's on bottom. Okay. So there will be, anytime we hit the top and bottom here, anytime we hit in those places, there's going to be vertical asymptotes. So like, for example, pi halves, negative pi halves, 3 pi halves, what would be another one? If we were going around the unit circle, we just were at 3 pi halves. 5 pi halves. How about 7 pi halves, and so on and so on. Everybody good with that? That's where our vertical asymptotes will be. Alright, now just a reminder that sine is the y value divided, and then cosine is the x value, so tangent is y over x. Okay, so if we don't know how to graph something, we plot points. So let's look at plotting some points here. So I would go ahead on my notes and write down all these x values right here real quick. We're graphing tangent. Now with sine and cosine, we only picked pretty points, so we just picked here, 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 and here for sine and cosine. But there are more pretty points with tangent. If you think about it, tangent is y divided by x. So at all the 45 degrees are also going to be pretty points. Because won't they always be 1 or negative 1? Yeah. So we're going to graph some more points on tangent. Okay, let's first start at negative pi halves. We just talked about how that would be dividing by 0, right? So this is undefined. Negative pi halves would be undefined. Once again, our undefineds happen here and here. Anytime it hits that place. So then let's look at negative pi fourths, which is the same thing as negative 45 degrees, which is right here. What would be the y divided by the x value? Negative 1, wouldn't it? Okay, let's move on to 0. Now 0 is the y divided by the x, so 0 divided by 1, which is 0. Let's go to 45 degrees. I'm just working my way around the unit circle. I did start in, notice, in the negatives, which is kind of interesting, because we never did that with sine and cosine. I'll explain why in just a second. So right here at pi fourths, this divided by this is 1. And then we're back to undefined, aren't we? Anytime we hit the top or bottom of the unit circle, it's going to be undefined. Alright, so look, now we're back to undefined. So what do you think is going to happen here? Negative 1, 0, 1, undefined, right? Are we back to undefined? Negative 1, 0. I'm just going a couple, like, we could go on forever here. This pattern is going to continue. Okay, so what I want you to notice is a couple things. Tangent is a little different than sine or cosine because our tangent repeats after pi amount, doesn't it? It starts repeating after only pi in length. Look, from undefined to undefined was pi in physical length. From negative pi halves to pi halves, do you guys see how that's pi in length? And then we repeat. So our period for tangent is not 2 pi like sine and cosine. Our period for tangent is pi. So our formula we're going to use instead of 2 pi over b is just pi over b once we start changing our period. Does that make sense to everybody? Yes, no, you got to speak to me. Okay. And then once again, noticing this is really important that vertical asymptotes happen at the top and bottom of the unit circle at all the pi halves parts, 3 pi halves, and 5 pi halves, and 7 pi halves, and so on. So now if I was to, these are the same xy points. They're not any different. I've just lined them up I've just lined them up in order here. Let's look at graphing this. All right, let's start at negative pi halves. So somewhere right here, negative pi halves. So at negative pi halves, we're undefined. That creates a vertical asymptote. So that would be the first thing I draw in here. I'm going to go, if you don't mind, drawing all my asymptotes first. So I've just plotted that one, that on the x-axis, and then I'm going to go over to pi halves. There's our next vertical asymptote. So then my next one will be at 3 pi halves. Let's do a couple cycles here just for fun. 3 pi halves. So then the next one would be at 5 pi halves, wouldn't we? I've done a ton of cycles here. But I'm just filling it in because it's pretty easy. Okay. So we've just graphed all the undefineds. Okay, next thing is, let's plot points. So let's see. At negative pi fourths, which is right here at negative pi fourths, we are down at negative 1. So here's negative 1 and here's 1. So at negative pi fourths, we're down at negative 1. At 0, we're at 0. Here's 0. So at 0, we're at 0. And then at pi fourths, which is right here, we're up at 1. So over pi fourths, up at 1. And there's one cycle. So let's connect them. We have this point, and this point, so it's circling down, hugging the asymptote, circling up, and hugging the asymptote. And then the pattern starts over. You guys see? So tangent is increasing. That's one thing to note. Tangent is increasing. So what's going to happen here? Well, in the middle, we're always going to hit at 0. If the pattern repeats, guys, the period's going to look the same, isn't it? So the halfway point, it's going to be at the 0. And it's increasing. So halfway between here and here will be down at the amplitude of -1. Halfway between the 0 and the asymptote will be up at 1. If cycles repeat, I'm just repeating the same cycle over and over. I have 3 periods graphed right here. Everybody understand? Okay, cool. All right, so key things to remember, guys. We're not going to use the parent function like we have with sine and cosine, because I just think it's extra hard. Harder than it needs to be. So everybody listen. This is how I teach this one, which is different. I just want you to notice some key things, and we're going to use that and build off that. Technically, here's our parent function, everybody. What we're going to do is now we're going to be shortening periods, lengthening periods, and so on. Just stretching, compressing, making amplitude smaller and bigger. But not a whole lot changes here. The key things don't change. So what I want you to notice is with tangent, it is split. The first period is split evenly over the y-axis. Do you guys see? This is pi in length, isn't it? The first period is going to be split evenly. So this is why in tangent, if I started at 0 like I did with sine and cosine, we'd only have half a period showing first. And I like to have my first period show fully. So that's why I had to go back into the negative. Does that make sense? That's the key thing to remember though, is for tangent, it's split evenly. The first period will be split evenly over the y-axis. Then what I want you to notice is the 0 will always happen exactly in between. And then tangent is increasing. So once again, you're going to go halfway between the 0 and the asymptote, go down to the amplitude, halfway between the 0 and asymptote, and go up the amplitude, and then just connect our dots. So noticing those key features is really going to help you. Okay, so now let's change some things. Let's change our amplitude. Let's change our period. So everybody write this one down. Now you do have to remember that period's not 2 pi over b. For tangent, it's just pi over b. So in this one, we would say our amplitude is 3. So I could go to my little xy axis, 1, 2, 3, down 1, 2, 3. And then from here, our period is pi divided by b, which b is 1/2. Do you agree? There is a half a cycle from 0 to pi. So now to complete a full cycle, we're going to have to times by 2, aren't we? So our period is what? Now it's 2 pi. Does everybody see? So the first thing I'm going to go do is draw in my asymptote. So let's draw in our first asymptote. Remember, our first 2 asymptotes are going to be split perfectly over the y-axis with tangent. I'm going to draw in another cycle, and I'm going to draw in one more. A couple cycles here. So if this length from here to here is a physical distance of now 2 pi, what would be the x-axis right here? Negative pi. Does everybody see how we cut it in half? So right here is negative pi, and this would be pi. Now everybody look, another 2 pi in length here would be pi plus 2 pi, which would put me at 3 pi. Plus 2 pi is 5 pi. So these points are my asymptotes. Any questions on that? Okay, now we go to the halfway point in between. So 0 is the halfway point. What would be the halfway point here? 2 pi, everybody, right? How did you get that? You added up 1 pi plus 3 pi. You found the distance, which is 4 pi, and then you cut it in half, divided by 2, which is 2 pi. 3 pi, so this would be 4 pi. Now, all I'm going to ask for you to label is your asymptotes and the halfway point. I don't need the other points. That's okay. This is enough. So then from there, plot points. So we know that for tangent, the 0 will be in the middle, and it's increasing. So we go halfway between the 0 and asymptote, and we go down the amplitude of -3. halfway between the 0 and asymptote and go up positive 3. And then it's hugging our asymptote. Make sense? And we've just drawn 3 cycles in.
Do you always want us to do 2 cycles?
I want you to do a couple, yeah, with tangent. Yeah. At least, I know a couple means 2 technically, but 3 is good. 2 or 3. I also did not have you do, I was just for kicks and giggles, guys. Look what happens here. I just want to show you something. If your calculator's in degree mode, if your calculator's in degree mode, notice we obviously cannot, if you type in tangent of 90 degrees, then it will say error because there's an asymptote there. But look, we can get really close to 90 degrees. That's okay. Look, if I plug in tangent of 89.9, it gives you 572. So that's like going over almost to 90 degrees and going clear up to 572. It's really, you guys see how it's increasing? So the closer you get to 90, the more it's growing to positive infinity. Does everybody see? So, yeah, basically it's just going to hug this asymptote. I was just kind of thought you might find it interesting. All right, let's try one by yourselves. Ready, go. So did you get a period of pi thirds? So then the distance from here to here is pi thirds. Same here. From here to here is pi thirds. From here to here is pi thirds. That's what period means, is length of a cycle. This is 1 cycle to 1 cycle to 1 cycle. So then if we have to label the x-axis then at the asymptotes, we're going to have to do a little math here. So pi thirds is cut evenly into 2 portions. So times it by a half. That'd be pi 6. So this would be negative pi 6. This would be positive pi 6. Now think about it, guys. If this is pi 6 and we're adding another pi thirds, you'll do into your calculator, just to be quick, 1/6 plus 1/3. Math, enter, enter, and you get a half. So this is pi halves. Now, how am I going to get this point? Take a half and add it to a third. Math, enter, enter. We get 5 pi 6. So this is 5 pi 6. You guys see how I'm adding 1/3 to 1/2? So then we fill in the halfway point, which is 0. Right here, halfway. Right here, halfway. So guys, how would I get the halfway point between these 2 points? It's just a distance. This plus this divided by 2. Now guys, don't type in the pi part, so just do 1/6 plus 1/2 and then divided by 2. Math, enter, enter. Pi thirds. So then you do the same thing here. You do 1/2 plus 5/6 divided by 2, and you get 2 pi thirds. And now I've labeled the x-axis appropriately. So now we'll fill in. We'd say tangent is increasing, so we'd put in our zeros, the halfway point, and then up at the amplitude, down at the amplitude. First hour didn't seem to think so. Is that making sense? Okay, I want you to let's just look at this one together so we can keep going quick. Okay, so looking at this one, our amplitude is 3, and then it is reflected. So we got to keep that in mind. Our period is pi divided by 2, right, everyone? Okay, so let's just do 2 cycles on this one. It depends on what you mean by negative. Right, yes, true. Instead of increasing, it will just be decreasing. So if this is, once again, pi halves and length, it really helps on the test when people draw this in, because then they remember what this means. So then from there, we have negative pi fourths right here, don't we? And then this would be pi fourths. And then you do pi fourths plus a half, right? Yep, 3 pi fourths, good enough. I'm doing just 2 cycles. Halfway point, 0, and then a fourth plus 3/4 divided by 2. So then we would just say, now our amplitude is 1, 2, 3, down 1, 2, 3. So then we're going in between is the zeros. And now, yes, normally we are down here at this point, but because it's reflected, it's actually up here now. And over here, it's now going to be down. So it's just now decreasing. Everybody good with that? Okay. Just thinking distances and tangents, not that bad. All right, let's now look at cotangent. So cotangent is just similar to tangent. The graphs are very similar, but there are a few key differences. They actually look very similar. So cotangent is cosine over sine. So this time, sine cannot be 0. So once again, sine is the y value. The y value is 0 here and here. So our asymptotes are actually at different places for cotangent. So it's at any time it hits either 0 or pi in that place, or any coterminal angle. So 0 is undefined, and pi is undefined. So then wouldn't 2 pi be undefined? So that's also in the same spot. Okay, now we're just plotting points just like we did with tangent. So pi fourths right here, 45 degrees, is 1, isn't it? Pi halves is going to be, this one's the x divided, the x divided by y. So 0 divided by 1, 0, and then at 3 pi fourths, which is right here, we're going to get -1, and then the pattern starts over. We're at undefined. So it'll be 1, 0, -1, undefined. So notice our first asymptote for cotangent is at 0. So right here at 0, like sine and cosine, we actually can start at 0 for cotangent. So then right here is, here's 0, here's pi. Let's do 2 cycles. Here's 2 pi. Then our halfway point here is pi halves. This is 3 pi halves. Isn't that where our zeros are? Halfway between, just like with tangent. Look at all that, look, pi halves, and look at 3 pi halves. You guys see how those are the zeros? Just like with tangent. That is, it looks almost just like tangent. And then notice at pi fourths, we're up at 1, and at 3 pi fourths, we're down at 1. So what does it look like? Yeah, it's a tangent that's been reflected, isn't it? Yeah, and shifted, but yeah. So cotangent is decreasing. That's the one thing to remember. It works the same as a tangent, it's just decreasing. But those same patterns exist. Yep. So notice once again our period for cotangent is just pi, because it starts repeating after pi amount. Okay, let's graph a cotangent that has a shift, or just a change to the period. Okay. So I put up tangent and cotangent. That's something you're going to kind of have memorized going into the test to make your life easier, that is. Obviously, you could go through and plot points if you forgot how to graph it, but most people kind of have a hard time with that. So notice tangent is split evenly over the y-axis, but cotangent starts at 0 over. Do you guys see? That's the one key thing to remember. But their periods are the same. And then tangent's increasing, cotangent's decreasing. Okay. So now we're doing 2 cotangent of 2x. So our amplitude is 2. So you'd go up 2 units, down 2 units. Then you would say my period is pi divided by v, so pi divided by 2. Now for cotangent, the first asymptote always starts at 0. We're taking that parent function and we're shifting it, so still going to be at 0. Then that would change our asymptotes. Yes, that would just change your asymptote. So let's do 2 cycles. Alright, so now guys, remember a cycle means length of a period, means length of a full cycle. Ours is pi halves in this one. The length from here to here is pi halves. So if that's true, and this is 0, then this is pi halves, obviously, right? Pi halves plus pi halves is pi. Then we're going to fill in our halfway between mark. So this is pi fourths. 1 pi fourths, 2 pi fourths, so this would be 3 pi fourths, 4 pi fourths, right? Okay, so then from there, 0 will be the halfway mark here, and then cotangent is decreasing, so it'll be up at the amplitude, down at the amplitude. Pretty easy as long as you can remember the specific patterns. Do we have any questions on cotangent? Okay. Okay, let's look at graphing cosecant. These are actually my favorite to graph. So cosecant x is technically the reciprocal of sine. So this is 1 over sine of x. So because we're dealing with fractions, we once again still have asymptotes. Because once again, sine of x cannot be 0. Now, I'm going to show you the easiest way to graph this. I'm just going to get right to the point here. What we're going to do is we're going to just graph like a sine. This isn't a sine. It's the reciprocal of sine. But if we have our sine graph, we can use that to graph cosecant. So what we're going to do is just look at graphing sine. Y equals sine of x, first of all. So if I was to say graph y equals sine of x, you would make an xy chart, 0, pi halves, pi, 3 pi halves, 2 pi. There's one cycle. And then sine's pattern is 0, max, 0, min, 0. So if I was to graph that, 0, pi halves, pi, 3 pi halves, 2 pi. So then up 1, negative 1. Okay, plotting points here in yellow. So 0, 0. Now, I'm not going to actually graph sine. I'm going to do this like dotted. Sine is not actually what we're graphing. This is just going to help us graph. So I actually don't have this yellow sine function. Now, everybody look how this would be useful. Isn't it true that the sine can't be 0 in this one? So where, look at this x-axis. Where is it 0? 0, pi, and 2 pi. Isn't that where the function's at 0, everybody? So right there is literally where the asymptotes are. Anytime that your sine function hits the x-axis, we'll draw in vertical asymptotes. So it makes it nice and pretty. Does everyone see? Okay, now plotting some points, and then you'll see the pattern, and you'll never have to plot points again, similar to tangent. You won't have to think about it much from here. So looking at pi fourths, everybody, pi fourths is just right here. Right here's pi fourths in between here. So at pi fourths, what's our y, what's cosecant? So what you would do is go to pi fourths. Looking at our y value, you would reciprocal it. So 2 divided by root 2. Let's do a decimal. It's easier to plot decimal. 1.4. So I'm over pi fourths and up 1.4. I'm up here a little bit. Then at pi halves, 1, the reciprocal of 1 is 1 over 1, which is 1. So at pi halves, I'm up at 1. Do you guys see how this point matched up perfectly with my sine? And then over here at 3 pi fourths, notice, at 3 pi fourths right here, the reciprocal, the cosecant, will be the same as 1.4. So I'm over 3 pi fourths up 1.4. So then now connect your red dots. They're approaching the asymptote and going up. So what happened? Well, our hills become valleys, or smiles become frowns. It's a reciprocal. Reciprocate a smile, it becomes a frown. Reciprocal frown, it becomes a smile. Do you guys see how the frown became a smile? That's always going to happen. So right here we have a smile, it's going to become a frown. The point will match up perfectly, and then it will just frown. And that's one cycle. I know, right? No, great question. So cosecant still has a period of 2 pi. So this all together is just one cycle here. Great question. Okay, so just remember that pattern. That's always going to happen. So let's graph this one. Write it down in your notes. We're actually closing down close to the end of the lesson here. Okay, so what we would do is start out like this. You'd say y is equal to 2 sine of x plus pi fourths. So then you're going to figure out your sine, graphing your sine, a rough sketch for sine. So x, y. These are a little bit more time consuming because we have to do our parent function. 0, pi halves, pi, 3 pi halves, 2 pi. It's a sine, so 0, max, 0, min, 0. We're timesing our y values by 2. So this will be 0, 2, 0, negative 2, 0. And then we are taking and adding pi fourths, aren't we? Right pi fourths. Our period didn't change, so we can just shift right pi fourths. So 0 plus pi fourths is pi fourths, right? Oh, crapola. Left pi fourths. Hey, if you don't mind, let's hurry and write down the new parent function's point. Sorry, left pi fourths, you're right. Subtract pi fourths. So negative pi fourths would be my first one, wouldn't it? Then you could do 1/2 minus 1/4. Math, enter, enter. 1/4. Oh, if you could do that in your head, you're awesome. Just kidding, that's really easy. Okay, then right here, check, check. And then 1 minus a fourth, right? 3 pi fourths. So then this would be, isn't it going to be 5 pi fourths? 5 pi fourths, and this will be 7 pi fourths. Okay, so let's start here. Let's try negative pi fourths. Then the next one was pi fourths. Then it was 3 pi fourths. I'm going to draw in 2 cycles now. So then 5 pi fourths. That's a 4. 7 pi fourths. 9 pi fourths. 11 pi fourths. 13 pi fourths. Okay, let's see here. Okay, so let's plot points now. So right here at negative pi fourths, we're at 0, max, 0, min, 0. 0, max, 0, min, I didn't finish 0. So sine isn't actually here, we're just doing a dotted line because it's just going to help us graph. Now isn't it when it hits the x-axis, that's when our function is 0? Which is a no-no, we can't have it be 0. So you'd now go drawing your vertical asymptote wherever it touches the x-axis or crosses. Okay, and then, do you guys feel confident from here on what to do? Go to here, frown becomes a smile. Pretty easy, as long as you can graph sine and cosine. Okay, so what do you think is going to happen for secant? Well, the same thing. It's just going to be with cosine. So all we have to be able to do, guys, is graph cosine. Cosine cannot be 0, so you'll just, wherever it hits the x-axis, draw in your vertical asymptotes, and hills become valleys. The exact same idea. So I'll just do one last final example here, and then you guys can work on the homework. So you would go y equals cosine of 2x. So then you would make your xy chart. Cosine is max, 0, min, 0, max. Nothing changed with our amplitude. We've just got to fix our period is 2 pi divided by 2, which is pi. So we're going to times these by a half. So we get 0 still, pi fourths, pi halves, times by a half, we get 3 pi fourths, times by a half, we get pi. Then cosine was max 0, min 0, max, max 0, min 0, max. Then we'll draw in our asymptotes wherever it crosses the x-axis is this where it's 0. And then our hills become valleys. So right here's only a half cycle. That's okay. I'm not worried about it. Because I know I can just draw it in like this, can't I? You guys feel confident graphing the other types of functions here? Okay, you have 30 minutes to work on the homework.